Hi, welcome and good morning. Welcome to this April webinar of DigiPrint Supplies entitled Get Out of the Dark About UV Lamps, or Shedding Light on UV Lamps. And that's what we're going to talk about today, UV lamps and everything around UV lamps. And the purpose of this webinar is to help you better understand how they work. So we're going to look a bit at the background of the technology involved with UV lights and UV curing. And then we will look at a couple of possible issues that you can have with UV lamps, looking at your UV lamps and what these issues tell you about what's wrong with your UV lamp or your UV system. As with all the other webinars we did in the past, the chat will be opened at the end of the session, so you can ask your questions and I will do my very best to answer those. I'm going to share my screen so that you can see my presentation. Just a second for that. So let's go full screen. So UV lamps. Let's start with UV technology in inkjet printing. If we look at a UV lamp, there's a schematic of a UV lamp here, then I think it's important for you to understand some of the things that we will walk through or explain, that you understand the terminology used for UV lamps. So it's basically very simple technology. It just involves high voltage and a lot of power. There's a fused quartz tube, right? So it's quartz glass that makes up the majority of a UV lamp. There's end caps, which are usually made in ceramic, and there's a wire. So you can see the wire on the left and the right in red. You can see the end caps, which are white, and then you see the electrode behind the heat reflective material. That electrode, the job of that electrode is to create an arc between the two of them, so that the mercury gas inside the UV lamp, inside the fused quartz tube, will start to ignite and send out UV light and UV energy. Okay, so a little word on the heat reflective material. Some lamps have it and some lamps don't have it. It looks like a golden coating on the ends of the lamp. And the reason for this, when the lamps have it, is that when you shut down the lamp, when you cool down the lamp, this heat reflective material will keep the ends at a slightly higher temperature to avoid that the mercury will settle at the end of the lamps behind the electrodes. And we'll see in a couple of slides that when that happens, it is a big issue for your UV lamp. Okay, not all UV lamps look like the one you see on the screen here. They might look like this as well. This particular one looks like a rather big lamp, but you can see that only 1/3 of this entire lamp provides an arc. So you can see the arc length there between the two electrodes, and that is the distance that is functional for UV curing, for curing of UV ink. So despite the fact that this lamp is rather big, it has a rather small effective working area for curing UV ink. And of course, it's very important that the arc length matches the print head setup in the carriage of the printer. If you can print at high speed bands of, let's say, 10 to 12 centimeters, like some QTech printers can, for instance, then you're knotting with a lamp that has an arc length of only 6 centimeters. So your lamps need to match your print heads. That's a basic idea. All right. So how do they work? Well, like I said, you have two electrodes, one on the left and one on the right side of the lamp. And when you send a pulse of high voltage between them, they will create an arc. The arc will vaporize the gases that are in the quartz tube, and this will generate light and UV energy. Now, if we look at the electromagnetic spectrum, you can see there the visible part, which is a part that we can see, and then to the left you have the gamma rays, X-rays, and ultraviolet. To the right, you have infrared, microwave, and radio waves. And in the ultraviolet spectrum, there's basically 4 types defined depending on their wavelength, which is UVV, UVC, UVB, and UVA. And UVV is not used in UV lamps. You only have UVC, UVB, and UVA. UVC is the part that makes sure that you can cure the deeper regions. The UVB and UVA is the part together that will make sure that the UV light can travel all the way down to a printed ink layer, and UVC is what is used to cure the top of the UV ink. Okay. Now, type of lamp is defined by the gas used inside a quartz tube. In inkjet printing, because UV lamps are of course used in a lot of industries, and not only inkjet printing, they are used to cure fingernails, they are used to disinfect certain materials, they are used in coding and marking, etc., etc. But in inkjet, large and super wide format printing, we can see about 3 different types of gas used in UV lamps. There's iron metal halide lamps, which we call dope lamps, because they, next to the mercury, they contain noble metals like gallium or iridium that help the lamp to reach the higher temperatures needed to do the effective curing. Then there's pure mercury lamps, and then Zund used to have lamps that contain lead as well. Now, LED lamps, of course, they are quite difficult to dispose, and they're not particularly cheaper than iron metal halide lamps or mercury lamps. Okay, iron metal halide can achieve the higher temperatures needed to cure certain inks on certain substrates, but they are extremely sensitive to overheating. So you need a very good cooling system to do proper heating. Okay, so what happens when they overheat metal halide lamps is that they will form what they call a on the quartz tube. We're talking about a quartz tube. They will form some sort of film that will make the lamp, well, basically useless, because it can't send enough UV light and UV energy through that film anymore. So the thing to remember, iron metal halide lamps, if you use lamps like this, like in the Agfa Annapurnas, for instance, or iron metal halide lamps, you have to take very good care of the cooling system. That means that you have to very meticulously replace the filters and take care that the fans can operate freely and in good condition. So vacuum clean the fans, for instance. Okay, and also the airflow. You need to keep an eye that everything around the UV lamp cassette or housing is clean, and that nothing can interrupt the airflow around those lamps. So a small word on the spectral output, or the wavelengths of the lamps, which you can see in the bottom of this slide. The mercury vapor lamp has a standard wavelength, or workable wavelength range from 254 to 365. Now, iron iodide lamps, which are doped lamps as well, and gallium lamps, they enhance the UV output to 410 or 415. So basically, that means that, again, what I told you about the metal halide lamps, the doped lamps, they need a very good cooling system because they generate a lot more heat, and they don't necessarily are more effective in curing. That's the downside of it. Right, so if you look at a UV system, what parts are involved? You have a power supply. We'll have a little word on power supplies later. You have a controller on your irradiator, and an irradiator is just basically it's a combination of reflectors and lamps. And that combination sits in a housing which we call a lamp unit. You have the lamp fans, lamp filters, and there's a quartz window on the bottom of the housing that helps to diffuse the UV light that is generated by the lamp and the reflectors. So, of course, if you place a lamp, and one of the questions very often asked about UV lamps is their lifespan. How long do they last? Well, we'll go into detail on that a bit later, but let's first look on how they age. And if a lamp ages, it doesn't stop working all of a sudden, all right? Very end, it will stop working, but it's not like they last at, let's say, 200 hours at full power and then they stop. No, they gradually lose their power. When the lamps stop to work, it's usually the electrodes that are eroded. These need to send a spark every time that you switch on your UV system or your UV lamps. And at a certain point, there's not enough left to create those sparks. Little parts of the electrodes will be thrown into the lamp envelope, and if it is a metal doped lamp, it will combine with the metals, and it will start to deposit on the end of the lamps, so making the lamp less effective. So since they combine with metals, doped lamps have a shorter lifespan than the straight mercury lamps. And usually when a lamp starts to reach the end of its life, you can see that that they have a sort of greenish glow to them. Some doped lamps have already a greenish glow, so that won't help you very much. The ones with iridium, for instance, already have a greenish glow. But for standard mercury lamps and metal halide lamps, if they start to have this greenish color, which is hard to see because you're not supposed to look directly into UV light, of course, but you can see it when your carriage travels over the media while printing, and there comes this greenish light from beneath the UV unit or the UV lamps. Then you can say, okay, this lamp will not last very long. So how do they age? That's what we saw. What is causing them to age? So there's a couple of things. First, of course, how clean is the lamp? And you will see that if you handle lamps, you should always handle them with a lot of care. Wear gloves, clean them before you place them in a two-step process. Same goes for the reflector, because you might argue, of course, that the UV lamp is the most important part of your UV system. But the reflector is at least as important as the lamp, because it provides 70% of the UV energy for the curing. So 30% comes from the lamp, it goes directly to through the glass, and then 70% is reflected by the reflectors dropping on your media. So the reflector is very, very important and very often forgotten. I have seen a lot of people that haven't replaced reflectors in years. They try to keep them clean, but at a certain point, they will start losing their effect, of course. So the quartz window, of course, if that's dirty, then yeah, okay, you won't have full curing. And the color coverage of the ink and the texture of the substrate are important as well. It will affect the aging of your lamp, and that has to do with the reflection by the ink and the coverage and the substrate. And then finally, the ambient air temperature and humidity have an influence on your UV lamp and your UV lamp system as well. So look a bit at UV ink. You can see on the right in the drawing the UV ink components. So you have monomers, you have pre-polymer, which are actually oligomers, and then you have photoinitiators, pigments, and some additives to keep it liquid. Now, if you look at wet ink, you will see the oligomers and the pre-polymers and the monomers and then the photoinitiators. As soon as these photoinitiators see UV light, they get excited, and they will start to stimulate the bonding process between all the other molecules in that layer of ink. And when that happens, they will start to combine, and that's what we call curing. It will start to polymerize and start to get hard, the ink. Now, as you know, on your UV printer, when you're printing and you're curing, the media comes out and it's dry. It's not completely cured. Ink usually needs up to 24 hours to be completely cured. That means that that process where oligomers connect with monomers in your ink is only completed after 24 hours. But your UV lamps are powerful enough to have that curing up to 80–85%, so that it is already dry and cured. It's not completely cured yet. That's the only thing. All right. So lamp issues. Let's talk about lamp issues. You can have several issues with UV lamps, and we're going to look at what can be the cause and what can be the remedy for them. Okay. So clouding. Let's start with clouding. And that's when a quartz converts back to a crystalline structure. And you can see on the image on the left, the glass is gone completely white. This is an extreme example, of course. The reason that this happens is always surface contamination, combined with too much heat in your UV system. It can be a complete film, like in the image, but it can also be white spots on the surface of the quartz body. How does it get contaminated? Your hands, for instance, the grease on your fingers. It can be paper dust. It can be ink dust that sets on the surface of the UV lamp. Okay. If the heat is too high, of course, you need to check your cooling system and have a look at that. The fans and the filter. Replace the filter. Maybe replace the fans if they're not effective anymore, or at the very minimum, clean them. Mirror coating, that's actually tungsten and mercury condensing. Tungsten is the material used for the electrodes, okay? That has to do, again, with inefficient cooling. But in this case, the heat is too low, all right? So inefficient cooling, it should be more like too effective cooling. And it looks like a mirror-coated effect on the inside of the lamp, like you see over there. So the things to check here is the power supply, and the cooling. If you have this on your lamps. If you have black ends on the left and the right side of your lamp, sorry, not your amp, that's natural. It starts after a while. If you have a lamp and it has been on for like 20–40 hours, you will already see a little bit of blackening. That's the electrodes that start to erode, and tungsten that sputters against the inside of the UV lamp. This will increase over the life of the lamp, and it is one of the reasons why your UV potential, the UV energy and light sent by the lamp, is decreased. And if you want to have a minimum of blackening on the ends of your lamps, then you should avoid switching lamps on and off. Most modern UV printers have a standby mode that keep the lamps at 50 or 80% of their power. Each time you switch a lamp on and off, the electrode will erode, throwing tungsten inside the lamp. So it's really a matter of trying to avoid that. If you switch off your UV system, you need to keep or make sure that the lamp is completely cool before you switch it on again. That's why every printer manufacturer of UV printers will tell you, if you switch it off, wait 5 minutes, then switch it back on again. All right. Yeah, okay, bowing, deformation, that's something that will happen with longer lamps. Lamps in UV printers are generally not long enough to see bowing. However, I have seen it on certain printers, and one of the ways to avoid it is to rotate the lamp 180 degrees every week. It also means that the temperature of the lamp is too high, above 850 degrees Celsius. And to give you an idea, the optimum temperature for a mercury lamp is 700 degrees Celsius, and for a metal halide, you need 800 degrees Celsius. Above 850 degrees Celsius, what actually happens is that the tube stability is compromised, and the quartz glass that makes the tube will start to, well, melt. Basically, it will start to take a liquid form, not completely, of course, but it will make it soft, and it will start to bend just by gravity, basically. All right. Everything below 650 degrees, Jesus. Everything below 650 degrees will, for metal halide lamps, will make the metals in the lamp start to condense. Okay, and which basically means that if it is below 650 degrees, no curing. Okay, external contamination, we already talked about that. Your fingerprints, they are the reason number one why things like this happen, but also paper dust and ink. It's again devitrification that will occur like in the first example, but only on certain spots. You should keep your lamps clean. You should clean them with isopropanol. Most of the lamps actually ship with a patch of isopropanol, and it's in there in the package together with things like this, cotton gloves. If you don't have cotton gloves, you use at least latex gloves when you work with lamps. And one of the reasons is that even if the lamp is completely new, clean it. You never know if somebody touched it or anything, and even only one fingerprint will lead to results like you see in the image on the left. You should clean it with isopropanol and then take a lint-free cloth and rub it again, clean it again, so that even the isopropanol doesn't stay on the lamp. Cap and seal damage, that only happens in two cases. When there is an overload or a very excessive high temperature, and another reason can be that the arc which is created between the electrodes did not happen to be created between the electrodes, but between one of the electrodes and an external piece of metal. We'll see that there are certain guidelines when you install a lamp as well. It might be the wrong lamp. It might be an error in the power supply, and it might be an incorrectly placed lamp. And every UV system, whatever printer you use, there's only one correct way to install a lamp. If the lamp is installed between, let's have a look at this one. You can see this is a Sub-Zero cassette, where you can see a very small lamp and here the reflectors. So it needs to be positioned in the middle, smack in the middle between the two reflectors. And then the depth as well is very sensitive. It needs to be completely correct because it's calculated how the lamp will send beams to the reflector, how they will reflect on your substrate. If it's a bit to the left, you will already have improper curing, like it passes over the media and there's a small band that is not cured, okay? Which if you didn't happen to notice and you let it cure over 24 hours, you will see some banding in that print. So placing the lamp, installing the lamp, if the lamp housing, the UV system is designed very properly, it's simply impossible to install the lamp in the wrong way. Okay, if you have a contaminated airflow, then you will have again the devitrification, which is quartz coming back to its crystalline state, but in spots. So there, fans, filters, airflow needs to be inspected. And then spiraling, that's when the arc is no longer stabilized, common with doped lamps, or more common, and longer lamps, and that's the transformer's fault, okay? It doesn't send the correct energy to, the correct current, sorry, anymore to the lamp. Good. You can have leaking, and like it is explained in the text on the right, in the unlikely event the UV lamp doesn't work out of the box, it's possible that this is due to leaking. And leaking is basically air that enters into the lamp envelope. I've talked about the end caps, which are ceramic, okay? Then you have the lamp, which is connected to the end cap. That part is cemented. So there's cement used to seal that completely. It is possible in very rare cases that that was not done properly and that you have a leak there. So air enters into the quartz body. And there's only one way that you can test this, and this is using a high frequency lamp tester. You have these UV lamp testers, which you can hold to one of the wires, and then you will see a purple glow inside the lamp, confirming that the lamp is still good. That kind of UV tester will not show this problem, okay? Good. Next to various lamp issues, you can have issues with the ignition of the lamps. And there's basically three methods that are used to power UV curing lamps. There's a magnetic choke with igniter, there's an electronic ballast, and there's a transformer. Magnetic choke with an igniter is a type of powering that is used in the smaller UV printers, like SwissQ Print, everything that uses V0 and Sub-Zero cassettes, even the Aqua Annapurnas. An electronic ballast, you will find that in Butek, Durst, and HP printers. And transformer, which is one of the best way to power UV lamps, is something that you will find in the very high-end UV printers, or to some extent in a different form in other printers as well. So magnetic choke, used in short arc length lamps. These are lamps under 8" or 200 millimeters. It's a very simple and cost-effective process. It can deliver up to 241 volts or 441 volt, depending on the type that is used. And the lead that goes from the igniter to the bulb should be 7 millimeters away from any metal lamp assembly component. We'll see an image of that. I have an image of that that tells you exactly what is meant. Okay. The igniters that you see in the pictures are igniters used by Aqua Annapurna, for instance. And the job of the igniter is to start the lamp, and then after that, its job is done, and it's the choke that will take over and send energy to the lamp in a continuous and constant way. So here you can see lamp installed, and you have the wire beneath the square block where the arrow is indicated with the 7 millimeters. So that's what meant. This has to have a distance of 7 millimeters to whatever metal part when you install that. Otherwise, you can't create arcs where they don't need to be, and you also can take. You also can create a current that overflows to the metal parts of your UV system or UV housing. Okay, ballasts, again, used in short arc length lamps. So anything below 200 millimeters, which by the way is 20 centimeters, and an arc length of 20 centimeters, you will not find that quickly in inkjet UV printing. It has a higher efficiency. It makes sure that the lamp has a longer life, and it's a low energy consumption, but it's much more expensive than an igniter, of course. And then you have the transformer, which is used in longer arc length lamps. It's very reliable, and since it has current control, you can actually scaleless choose the current that you want. It's puts a lot less strain on the lamp when or the lamp electrodes when you ignite it. So this even results in a lamp life that is a lot longer than the electronic ballast or the magnetic choke and igniter. How do you handle lamps? Well, I already explained it to you. Wear gloves. Otherwise, grease from your fingers will end up on the lamp, and that will start devitrification, turning your lamp into a useless piece of glass. All right. Clean them before you install them with isopropanol wipes. Once you clean them with isopropanol wipes, wipe them again with a lint-free cloth or a lint-free wipe, so that they are pristine and very clean. You should clean the lamp UV system and the reflectors at least every 500 hours. But depending on the manufacturer of your printer, some manufacturers advise if you replaced a lamp 4 times, replace the reflectors as well. And like I already explained, the reflectors are responsible for 70% of the UV energy and light, so they are very important. We mentioned this as well. For longer lamps, rotate them every 100-200 hours or every week, so that there's no deformation of the quartz that is caused by gravity. Clean the UV system. Yes, everything around it. Make sure that it's no ink, paper dust whatsoever. It needs to be absolutely clean. All right. And in tests of UV lamp manufacturers has shown that for inkjet printing, companies that keep track of how they clean the UV system and really do it when it's supposed to be done, that they prolong the life of the lamp with a considerable amount. So I really would start to take a look at that, how you do it, and how often you do it. Yes, shut it down, allow it to cool for at least 5 minutes before you shut it back on. You turn it back on. All right. So lamps need to be completely cooled before you send the high power through the electrodes again. That's the message. Avoid excessive starts. And excessive starts is actually you start up the UV system, you shut it down, you start it again. So you don't take a 5-minute break for the lamps. This will decrease the lamp life very considerably. Okay. Then the reflectors, change them after you replace the lamp 4 times. That depends on the printer manufacturer. But most of all, keep them clean. And you clean them in the same way that you clean a lamp, isopropanol and then a clean cloth. They're not always that easy to reach. For instance, here, you can see that you will be able to reach these parts and here as well. But on the back side of the lamp, they're a bit more difficult to reach. But anyhow, do your best to clean them. They're very important. Yeah, if you replace lamps, replace them in pairs. I think that's logical. You want to have equal curing of your UV lamps on the left and the right side of your carriage. If you have an old lamp here and a new one there, then I can guarantee you banding in whatever you print. So you replace them in pairs. And then storage, you need to keep your lamps horizontally stored. Now, the reason for that is if you would store them vertically, like the example on the right, the mercury will start to get behind the electrodes in the space where you also have the heat reflective material, the golden end of a lamp, all right, here. And mercury will start get trapped there. There's a mixture of gas in a quartz tube, but usually argon and xenon, argon or xenon together with mercury, and then if it's doped, there's some noble metals added to it. And if it's trapped there, then the lamp will simply not start because the electrodes will send up the pulse. There's no mercury to be found, so there's no ignition of the lamp. Okay. Now, I understand that even if you store them horizontally, we store every lamp here in the stock horizontally, but then we ship it to you. And I have no idea what the courier does. If we put the lamps like this in a box and he puts a box like this, it's not stored horizontally. And therefore, you should, before installing a lamp, and I need to add, let's assume that in transport, they were transported vertically, all right, and there's mercury trapped behind the electrodes. You receive it, you put it on a shelf horizontally, and you keep it there for 24 hours. Well, honestly, you can keep it there for months. Mercury will not start to settle to the middle. It will stay wherever it is. So before you install a lamp, you should shake it. I know that you should take care and treat them as glass and being fragile, because that's what it is, what they are. But you should shake them before installing to ensure that any mercury trapped behind the electrodes is back inside the quartz tube. There's even customers that have these vibrating devices. They put the lamps on there before they install them. Of course, you have to make sure if you have a device like that, that they don't fall off. But you should shake every UV lamp before you install it, even if you store it horizontally. And that will make sure that the mercury comes back where it needs to be. If it's a doped lamp with metal halide and you shake it, you will see like metal balls inside the lamp coming to the middle. That's when you know that you release the mercury, because the mercury stays around the metal halides inside that lamp like that. If it's a pure mercury lamp and you shake it, it's possible that inside the lamp there's like a mist that starts to appear. That's also a sign that the mercury has been released, but it's not always the case. So you shake it for about 5 minutes, and if it's a lamp with long wires, you need to hold the wires as well. Otherwise, the wires might start to hit the quartz body of the lamp. So you shake it very roughly, but still taking care. I know it's a bit tricky. And then you install the lamp. If you install the lamp and it doesn't ignite because there's mercury trapped behind the electrode, then you take it out, you shake it, and you put it back. All right? So that's it. Let's have a look at what questions you have. I will first stop the sharing and open the chat for you. Here it is. And I'll be happy to answer your questions. I'm going to add, for the people that watch our webinars from time to time, they know this, but you can watch the webinar again on our Zendesk support website and on our YouTube channel as soon as it's available there. And usually that's today or tomorrow. Yeah, like I said, Avelino, you can watch it again and you can take the slides from there. Yeah. And we make them available for downloading as well. I see a couple of people typing. Gabriel, I must say that my Spanish is not what it used to be, but I think you make it available. I think you're asking me to make the presentation available as a PDF, which we will do. I think you mean, George, that you have poor curing at soft tone. So if you print like a lot of with the light cyan and the light magenta colors, and good curing at strong colors, are you using original inks, and what printer are you using? Thank you, Avelino. Dilip, I will come back to you. Bella, I don't really understand your question. Now, Dilip, not every lamp comes with isopropyl wipes or gloves. It depends on the type of printer. Jose, do you mean the igniters of your power supply, or do you mean the electrodes inside the lamp? If it's the igniters, then there's something wrong with the rest of the power supply. So if you have to replace igniters too fast, yeah, the electrodes, too much power sent to the lamps. What printer? Okay, outside. Then there's something wrong with the power supply itself. Um, Depending on the printer, we can see. I would open a ticket on our Zendesk website, Jose, and we can see what the requirements are and what the specifications are for your power supply, and have you measure that to see that it's still within specifications. No, George, I was asking for your printer model and the ink you were using. Annapurna, yeah, the Voslo igniters, yeah. Definitely check the power supply. So please open a ticket. Yeah, doesn't matter what ink, printer, or media you're using, there's always UVA wavelength that is used to cure part of it. But the three wavelengths, short, long, and middle, are necessary to have a complete curing. You can't say the name. Okay. Um, the thing is that if you have good curing on the CMYK colors and not so good curing on the light colors, and I don't even know if your printer Flora F1, yeah, I think so, has light cyan and light magenta, no? If you have less curing on that, then I would have a look at the inks, to be honest, because there's nothing else that makes sense unless, well, soft tones will also create a layer that is less thick than the full tones, and maybe, just maybe, your lamp is just slightly too far away. Although it probably would have to be a considerable amount that they are too high, your lamps, before you would start to notice that. So I would definitely take a look at the ink. Dilip, I don't know by heart. I should look that up. Sorry. I know the V0 140D, but the other lamp you mentioned, I don't know. Jose, no, no. You don't need to replace the igniters when you replace the lamps. You need to replace the igniters when they fail to start your lamp. So you only have CMYK, George. George, can I ask you to open a Zendesk ticket so we can look into that in more detail? Because I find it at least an interesting question. I'm sure you're printing now. If you go to our website, George, digiprint-supplies.com, and you log in like you would when you order something, then you have a big button on the top right on our homepage that says technical support. You click on that, and then you come to our support website where you can open a ticket and ask us your questions. You also find a lot of other information on that support website. Might be a good idea to check that out as well. If that fails, George, please send an email to this email address. Yeah, but the Agfa lamps or V0140D as well, Dilip, no matter what part number they give to it themselves. Uh, yeah, but even if you have a very small amount of ink, wait a second. Open the ticket, George. We'll look into it. I understand, Dilip. A lot of people typing. I wait for your questions. If you have suggestions for future webinars, I'm happy to hear them. Depending on the all the conditions around it, Svilin, Sub-Zero lamps are certified, if I'm not mistaken, for at least 500 hours, if not more. But there's always two things to consider. You have the lamp manufacturer which will put a lifespan on its lamps. Let's say that you make a UV lamp and you say this will last 1,000 hours. Then there's also the number given by the printer manufacturer, because the printer manufacturer might run it at a slightly higher temperature. They have between for a pure mercury lamp, for instance, between 650 and 715 degrees, and for metal halide, it's even between 650 and 800 degrees. So the higher power you run it at, the faster they will lose their life. So you have the printer manufacturer putting a life on it, and you have the lamp manufacturer putting a life. How long does your lamp last, Philan? Yes, George. That's exactly what it means. Avelino, we have done ultrasonic cleaning, I think 2 months ago. Please go to YouTube, type DigiPrint Supplies, and you will end up on our channel, and you will see not only our webinar about ultrasonic cleaning, but also all of our previous webinars, and also installation videos for print heads there as well. Yeah, Dilip. Oh, if you printed something on your UV printer, like I said, it's dry for 85%, but the complete curing is only after 24 hours. So if your customer needs what you printed fast, it's okay to give it to them. Except in certain cases, like when you print on corrugated plastic, for instance, it might be that when it comes out of the printer, that the scratch resistance and the adhesion is not optimal yet. So you can still scratch it off when it comes directly out of the printer, but 24 hours later you can't. But if you print on vinyl or on banner with your UV printer, no, ship it to the customer. You don't need to wait the full 24 hours to do that. Just be aware that for some substrates and image as well, because that will determine how thick the layer of ink is, that 24 hours might be what you need to get the curing that you want. Um, well, we looked at the possible reasons why UV lamps age, and it might be that the airflow is not optimal. There's a lot of power sent to the lamps to ignite them, maybe too much. They are run at a heat that is higher than in another UV printer. So I think it's so you printed on, what did you print on? Wood and aluminium, okay. And then you had a reaction between the lacquer you put on there and the ink. The ink started to wrinkle. Well, first of all, I think that you described the problem that or the reason why it happened is that the lacquer reacted with the ink. The question is, before you lacquered them, did you have good adhesion of the ink? Were you able to scratch it off very easily? Yeah, I think what you describe is your answer, that you had a reaction between the lacquer and the ink. The only thing that when you say it starts to wrinkle, it's like it starts to form a layer. So if it wrinkles, then maybe the scratch resistance was okay, but the adhesion certainly wasn't. Did you pre-treat the wood and aluminium? Did you use a primer for them? Because a primer can greatly enhance the adhesion of UV ink on certain materials, for instance on glass. So you did use a primer. Did you use that lacquer before on other materials? Yeah. Did you test the adhesion? Send me a mail about that, Dilip, to this mail address. That will not have the curing, Avelino. Okay, guys, thank you very much for joining. Dilip sent me an email, and I hope to see you again next month for our next webinar. Have a good day, and see you later. Cheers. Thank you for joining. Bye-bye.